Hey guys, let's take a look at number 36, unique paths 2. Uh, Actually, we have finished, we have done a similar question of number 62, unique paths. It's nearly the same, except that in number 63, there's one more condition, is that there might be some obstacles. We're given a matrix, and 1 stands for obstacle, 0 stands for empty. In the previous problem, all the cells are empty. So we need to check if the robot can move to the bottom right from the top left. I think the solutions will be the same, so I just copy paste the solution. If you haven't watched my video yet, please search on my channel for number 62, unique paths. There is a detailed explanation there. I first copy it here. So our basic idea is that is of the dynamic programming. Each whether the robot can move to the paths, right? Okay, the paths, the unique paths the robot move to the bottom right must pass this cell or cell, means the cell on the top or the cell to the left. So we can do this recursively and get the result. To that, we will keep a DP array, which means the steps to the cells in each column for a specific row, and then we will start from the toppest row, the first row, which are all initialized with 1 because there is only one direction the robot can move, and then we'll do and then we will calculate the second row. For each cell, it will be the sum for the left and the top. So we can keep only one array and do do n-1 iteration, and then finally we'll get the last result. But for the grid, we need to do some modifications, right? First thing is that we cannot just add up the left and the top, add up to the left items, left steps. Means the numbers cannot be some. This does not work anymore. We need to check if it is grid or if it is obstacle or empty. Yeah, the second one is that for the first row, they're not all 1. There might be obstacles. If there is one obstacle, the rest are all obstacles, right? Yeah, and so what we can do is that we can suppose there's the extra row, which is initialized with 0. Without make things simpler. So each cell will be left plus the original number, which always is 0. Okay, and the iteration was be not n-1 but n, so it's bigger than 0. And for each row, the thing is that okay, the first thing, the robot is the top left, so it must not be cell, right? It must be empty. So I can assume that the first is the virtual row we added. We update the first cell to 1, to wait, right, 1. Yeah, there's one possible paths. Okay, and then for the first row, and for each item, there will be 2 possibilities. The first is that it is obstacle. If it is obstacle, then it must be 0. There's nothing to do, right? Yeah, so we only check if it is not obstacle. So which means obstacle grid, the n. Okay, I'm not because the order matters now. So I will change the while loop for for loop, which makes it easier for me to understand. Okay, now so this will be J. Only update when it is empty. But is there any possibility that the left top to the left is obstacle? If that, what cannot be put there, right? We can just first ignore that. Okay, I and J. If it's empty, and then we can do the things. We can do the update. Okay, so it will be left plus itself. Yeah, if it's original it's obstacle, then this one is obstacle, then 0 0 it still be 0. So if not, it will be empty. Yeah, we need to update that. dp j equals 0. This should be j, this should be j, and this should be removed. Oh, there's another mistake. There's no n and n. Constant n equals obstacle length. Constant m equals 0.n. Okay, let's check if our solution is valid. If it is 0, okay, it will update it by whether it is obstacle or not. If it is obstacle, there should be no paths to it. So if both of them are obstacle, top and left is obstacle, the sum is 0. So this will be also 0, right? And if it's not one, is not 0. Yeah, I think it's working. So let's run the code. One assumption is that the top left couldn't be obstacle, but I'm not sure. I'm not sure whether all the test case. Oh yeah, look, there's a problem. Wait a minute. Wow. I opted 1. Yeah, there is a problem because if it is obstacle, wait, for only 1 here, we update it to 0 and then update it to 1, and then we loop through all the cells. If it is not, we update it to 0. Ah, God, this should be start with 0. And God, the first column also has the possibility of being obstacles. So we update it, and j is bigger than 0, then it's this. If not, it should be 0. Okay, to make things easier, I think we can just create an extra column, which means n plus 1. So dp1 equals 1. All right, and so I is okay. J will start with 1. J will this, and then dm. Okay, this seems nice. Let's run the code. So add the extra column to make things easier. Ooh, I missed length, so we extra fill with 0. The second row here should be 1. Start with 2. Start 1. Loop through it. J should be -1. Wow, this kind of like make things complicated. Let's just I'm sorry, this things is complicated, and we just add the check here. Run the code. Time is the same, I think. O N M space. Yeah, it's still O M. Submit. Yay! We run faster than 99%. Wow. And cool. So a dynamic problem. Hope it helps. See you next time. Bye bye.